All right, so the last time we started with sets and we went through the first couple of pages. So I get that some of you guys didn't look at it. So we'll do a quick run through, the quickest run through you've probably ever seen in your lives, right? Because we have to be prepared. All right, so sets, right? So sets give us a lot of information about a collection of objects or elements or sometimes members. So you can group these objects into different sets based on certain criteria. So whether it be a set of odd numbers, set of even numbers, you take from the universal set, which may be a set of numbers from, in this example, says 0 to 9. And then you could have 4, 7, 9 being one set, and another set 1, 2, 3, 4, 5. You can also create another set that could call it set C that just have the set of odd numbers, and another one could have a set of even numbers. So it's just a way to group members or group elements of a larger set, oftentimes as a universal set.
Sure, you hearing me?
Yeah, man.
Is there somebody saying you're to let them in?
Oh,
Okay.
thanks. Right? So that's the concept where we were able to group members, elements, objects, different certain criteria, and we name the set, whatever it want be, set A, set B, and so on and so forth. And then we'll have this Venn diagram where we represent,
Asleep, myself forgot sleep.
represent this graphically. So for example, in this set A, set B, we have 4 being common to both set A and set B. So we'll put 4 in the middle. Right? And the middle here where set A and set B overlap is referred to as the intersection. And then what we'll do is to fill the rest of the set with the different elements, right? Or members. So these are cutting here 1, 2, 3, 4, 5. Some books refer to them as elements, others refer to them as members, right? So A has 4, 7, 9. So the 4 is in the middle, is common to both A and B. And then 7, 9 fills out the rest of A. And then for the rest of B, you'd have 1, 2, 3, and 5. So 1, 2, 3, and 5. And then, of course, you have some of the members that are outside of set A and set B. So when you look here, you have 1, 2, 3, 4, 5, 7, 9. That's in both set A and set B. But you also have 0. That's not among these two sets. You have 6. That's not among them. 8. Not among them. And so you can expect those to be on the outside. There's 0, 6, 8, right? And that would complete the Venn diagram. So as I said before, where two sets of common elements, that's the intersection of the two sets. And of course, the union is all the elements that are in both the set A and set B. So this one, we did this the last class. Basically it asks to fill out the Venn diagram. So set A 1, 2, 3, 4, 5. Well, that's like 1, 4, 5, 7, 8. Set B is 2, 6, 8, and 10. So the very first thing you do is to look to what is common. Now, what's common here? We see 8. So 8 is common. So you put 8 in the middle, and then you fill out the rest of the set. So you say, all right, 8 in the middle, and then for set A, you fill out the rest of it, 1, 4, 5, 7. And for set B, 8 is in the middle here. So we fill out the rest E to 10 would be over here. Right, so we did all of this in the last class, and so you can refer to the video. Well, the solution, right? Right here, we have question speaks to the whole numbers 1 to 10 are organized into two sets, set A and set B. Set A contain all the odd numbers, set B contain all the numbers greater than 4. So you go and you say, all right, so set A contain all the odd numbers. So you're looking at R1, 3, 5, 7, 9 would be A, and then B. All the numbers greater than 4. Then when I say even numbers, like just all numbers greater than 4. So you have 5, 6, 7, 8, 9, 10. And of course, you would have some other odd numbers and in the set A overlapping with the numbers in set B. So if you think about it, 5 is an odd number and 5 is greater than 4. 7 is an odd number and 7 is greater than 4. So I'm just listing the common elements between two sets. 9 is an odd number and 9 is greater than 4. So those would be in the intersection. And then you fill out the rest now. Set A, you have 1, 3, and we said that 5, 7, and 9 is in the intersection. Then in B now, we would have, let me think, so you would have 6, would be in the B only section. And of course, there would be some numbers that are on the outside. So again, refer to that video. And we did this as well last time. Refer to that video, and we'll go down. So notation. So we went through this the last time too, but I'll quickly go through. As it's an intersection, so it's like an upside down U, and we spoke about it before. It's what's common between the two sets. We speak to, remember, the intersection is outside the middle here, where the sets overlap. Union is everything that is in set A and set B. So if set A has 1, 2, 3, and set B has 4, 5, 6, then A union B is just 1, 2, 3, 4, 5, 6. Everything that is in set A and set B. And of course, we don't repeat elements that are common to set A and set B. A complement just means not in set A, right? And we see more examples of this, what's not in set A, but you can find those elements in the universal set. So for example, if the universal set, which is that largest set or the largest set where it pick the elements from. So if universal set is 1, 2, 3, and set A is just 1, then A complement would be 2, 3. So it's everything outside of A. A being a subset of B just means that every element, as I say, every element in A is also in B. There's an example of a subset up here. B is a subset of A, right? Because every element in B is also in A. Of course, A has some other elements, but B is totally inside of A. So B is a subset of A. Going down now, back, should say, we have empty sets. Nothing is in there, right? So if you think of the intersection of odd numbers and even numbers, they don't intersect. So that's an empty set, right? Number of elements in A, just telling you the number of, well, might as say number of elements. So the ME number, and this is saying members in A. Some books will say elements in A, and even some will say objects in A. So, for example, if you have set A has 3 animals, cat, dog, squirrel, then number of elements in A is 3. All right. So come to this part now where we have an example. Um, and it's a worked example, so that's great. So you have the universal set 1 to 6. We have A, 1 to 3, B, 4 and 5. I just say 1 to 3. A is 1 to 4, sorry, and B is 4 and 5. Now it asks for the intersection A intersect B. You just look at what is common in A and B, and that would be an intersection. A union B, you just put everything that is in A and B together, and that would be the union. And then you have A complement, everything that is not in A, right? So you're looking for what's outside of A. Similarly, B complement, everything that is outside of B. And then the asked question is B a subset of A. This was also done at the last class, but quickly. So the intersection A intersect B, we look at set A, set B, intersection, what is common for? 4 is common, so that's the one and B, just with all of A and all of B together. A complement, we're looking at, all right, A contains 1, 2, 3, 4. So what is not in A, but is in the universal set? Well, 5, 6. So you say that 5, 6 is not in A. A just have 1, 2, 3, and 4. Similarly, B complement, B has 4, 5, but you're looking for what is not in B, but is in the universal set. If B contains 4, 5, then everything else would be 1, 2, 3, and 6. And that would finish off A to D. Then also is B a subset of A. If you look at B, B is 4, 5. A, 1, 2, 3, 4, is B a subset of A? No, because even though A has 4, A does not have 5, which is an element that is also included in B. So for B to be a subset of A, it needs to have 5, both 4 and 5, right? So moving down. So hopefully you guys getting the gist of things. You can ask a question now before I continue. No questions? Not hearing you. Everybody good so far?
Yes, sir, I'm good.
All right. All right, so nobody else is asking any question. Let us proceed. All right. So this says use set notation to describe the shaded region of these diagrams. So this is, you have the A circle, B circle, both sets, right? And then so where only the portion that is in B is shaded, right? So you see where the intersection, not even should just be only, they refer to this as B only, right? So the elements that are in B and are not in A, B only. And it is written as B intersect A complement, very important, right? So B intersect A complement. So it's saying, give me the intersection of B and the elements that are not in A. So if you look right here, so what is not in A? Everything outside A is not in A. Everything outside. And I think this deserves a screen. Let us see. So let me try and draw. Hopefully I can draw something, you know. So this is A, this is B. Let me change this to this. All right, so we have A and B. So A complement will be everything outside of A. So outside of A, outside of A, outside of A, everything outside of A. So that is A complement. So these elements outside of A. And then B now, B is, let me use it, B is this thing here. This is B. Of course, I cannot go outside of B a little bit, but you know, just think of it as B. Now, when you look at where both of them intersect, right, where the shading is overlapping, right? You can see that both the green and the red can be found in this area right here. And so that is how they come up with, if they want to write it this way, I'm going to write it this way as B intersect A complement. So that's how they get it. So example, let me give a quick example that may help you to understand this. If you think of a universal set, this is something I'm going to make up right now. Hopefully it's not too difficult to make up on the spot. Say I use 1, 2, 3, and 4 for argument's sake. And then B, let me clean up some here. I'm clean up this. And then B for argument's sake, probably should start with A first. Don't really matter. Start with A just because A comes before B. And say A is 1. Let's say A is 1. So A contains just one bigger element, which is 1. And then B, so for example, B contains, let's say 2 and 3. All right. So if I were to ask you what is A complement, I'm gonna ask you guys, what is A complement?
Sure, A complement
2, 3.
and 4. 2, 3, and 4.
Right.
No.
So
Yes.
2, 3, and 4. So that's A complement.
A
Don't touch it.
2, 3, and 4. Because they're not in set A.
They are not in A, but in universal set. So 2, 3,
Yes.
and 4. Right?
Yes, sir.
Now, if I were to ask you what is common between B and A complement, what would you tell me?
What is common between would be 2 and 3.
2 and
Those are
3.
common in both.
All right. And that is how we get B intersect A complement. So B
Okay. Would be 2 and 3.
and 3.
Oh.
Okay? So that's how it come about. But once I break them down in simple sets first, then you can easily just find the elements when you combine them with a union or intersection like this question. All right? So let me go back to the paper, right? The notes. Come on, get one disappear from me. All right. So, and that's it. So this one or this, the asks about what this is about here. And the answer is this is the intersection of A with the complement of B with the complement of the union of B and C. Now this is way more interesting, but with everything, if you can break it down and find the simple sets first, and what I mean by that, if you can find what is B union C, and after you find that set, then you find B union C complement, and you put on that set, and then you find A intersect B union C complement, then you can find this whole thing. So maybe we should attempt a question. I suspect they have interesting ones down here. Let me see. See, they have them. I think this is probably one of the better questions down here. So I'll leave you guys to meditate on this for a little while. Come back to me and tell me if it makes sense, right? Hopefully after doing these questions down here, we're going to try and attempt all of these. This is the bulk. Like if we can do these, then we're good to go. And then I want you guys to try these out for yourself. But all right, let me hurry up and get to it now. Let me try and get to this right here. So we'll have this one and this one. Let me see which one is the one to get to first. I guess I could ask you guys to check this one out. So attempt this, let me see. Attempt this one. I give you 10 minutes real quick. Attempt this one. Let me see what you guys come up with. For number
two?
Yeah.
Okay.
And I give you 10 minutes.